All right, guys, so this video, we're gonna go over exponentials and logarithms. They're two actually inverse function families that you guys have talked about in Algebra 2, you've used a lot in pre-calc, and they're going to pop up a lot when it comes to calculus, and we have to know how to use them without our calculator and how to simplify expressions to make them as simple as possible, to rewrite in as many different ways as we can so that we can really show our understanding of them. So the first thing that you're going to have to make sure that you know is how to convert between an exponential function and between a log function. So if this is the exponential function that I gave you, okay, a lot of us learned the loop-de-loop in Algebra 2 and in pre-calc. You can also learn more of an algebraic way to do it. Whatever way you do it, this is going to be this function rewritten as a log function. The way that I like to think about it when I'm dealing with exponentials is that an exponential, the inverse of a base of e, is going to be a natural log. So I'm going to take the natural log of both sides. When I take the natural log of both sides, I'm left with ln of y here. And then over here, since natural log and exponentials are inverses, they're going to cancel out, and I'm left with just x. Okay, so that's one way to think about it. The other way to think about it is the loop-de-loop way. So I like to use the loop-de-loop a lot when I have a log function. So I'm going to take the base of the log, I'm going to go to the answer, and then I'm going to come back to my input value. So 5 to the y is going to equal x. Okay. You could also think about it as raising both sides with the base of 5. That works as well. Either way, as long as you guys know how to convert between the two, then you'll be good. The next thing you need to know is how to simplify it. How to expand, I guess is what it's called. So log of a times b, I can break that apart. If I have two things inside and maybe one of them I know how to work with and the other one I don't, splitting it apart might help. And if it's multiplying on the inside, when you split apart your two logs, you're going to add them together. Okay? Very similarly with division, if I have two things inside that are being divided, and maybe I know how to work with one, but I don't know how to work with the other one, I can split them apart into two separate logs. But now I'm going to subtract if it's division. And it's always numerator first, denominator second. I also have, if I have an exponent, and I just don't want to deal with that exponent, I can pull it out into the front so that it's by itself, and then I'm left with just the log of whatever that base was. That's one of the very few times where you're actually allowed to kind of separate a base and an exponent. Usually they're pretty stuck together, but in this case, you can bring them out in the front. And then the last thing that's really important for you to know is that the natural log of e and the natural log of 1 are going to be, natural log of e is going to be 1 and the natural log of 1 is going to be 0. So if you think about your little loop-de-loop thing that we talked about here, these really have a base of e. E to the first power gives me e, and e to the 0 power gives me 1. Okay, anything to the 0 power is always equal to 1. So those are the big things that we really need to know when it comes to exponential and logarithm functions. Okay, now when we're doing this, we're also going to have to remember a lot of our properties of exponents too. Remember, if two things are being multiplied, you can add their exponents. If two things are being divided, you can subtract their exponents. You have your negative exponents as well. All of that stuff we still have to remember and to take into account. So if you forget your properties of exponents, I would actually make sure that you go and watch that video first here if you haven't yet, because that's going to help you with some of the concepts that are going to be used. All right, example 1. I have e to the natural log of x minus 2. So the tricky thing here is that this minus 2, a lot of us are always unsure whether, is that part of the natural log? Is it not part of the natural log? Is it sticking out at the end by itself? You're just not sure because there's no parentheses there. Well, if there's no parentheses there, that means that the natural log is only applying to the x, okay? So usually we could cancel out the base of e and the natural log and the exponent, but for this specific problem, I can't do that because of this negative 2 here. Okay, if the -2 was part of it, they would have put it in parentheses, but it's not. So we got to think about our properties of exponents. Subtracting is the same thing as adding a negative, right? So really, if I'm adding exponents, I could split them apart and make them multiplied. So this is going to be the same thing as e to the ln of x, and then times e to the -2. Because I know that when I'm multiplying two things, if I were to simplify it, I would add the exponents together. Here we're kind of going backwards and expanding, but the fact that we're expanding is going to allow us to simplify even more. Because here, those are going to cancel, and you're left with just x. Okay, e to the -2, I can't really do much with that, except for rewrite it this way, 1 over e to the 2. And then I'm just going to multiply those two out and get that for my final answer. Okay, just manipulating those numbers around, moving them around in whatever way you can that makes that expression a little bit more simplified, because this right here is a lot easier to work with than this. Okay. All right, number 2, let's change colors. E to the natural log of 4. So I'm going to go ahead and right away, e and natural log cancel out. I'm left with just 4. Now, some of you might be thinking, okay, why though? Why are we allowed to cancel that? The 4 is in the exponent. Why does the 4 come down? So let me give you a little bit of an explanation. If I say e to the natural log of 4, let's just say that equals y for right now. Okay, we're just going to make it y. If I take the natural log of both sides, the natural log of e to the ln of 4 equals the natural log of y. I just put a natural log on both sides. So my equation's still balanced. Remember, with exponents, we can bring this out in front. So I have ln of 4 times the ln of e equals ln of y, right? What's ln of e? Gone, it's 1. That's one of our identities we have to know. So if I have ln of 4 equals ln of y, y has to be equal to 4. So that's just a little bit of a proof there as to why you can just cancel out those and get just 4 there. Okay? All right, next one, e to the 4 ln of x. Now, it looks good, but this 4's throwing me off because I got a 4 in the front there. Just like I kind of had this -2 at the end up there. I cannot cancel that e and that natural log out yet. I have to somehow break it apart, get that 4 removed somehow. We got to figure that out. So there's a couple ways you can do it. What I like to do is I like to use this formula, right? If I have something in the front, I can push it up to the exponent. So I'm going to rewrite this as e to the natural log of x to the 4th power. So now that that 4 is out of the way, it's now part of that natural log. Now those can cancel out. And for the same reason that I did over here, right? When I cancel them out, I'm just going to get x to the 4th. Okay? All right, we're starting to get the hang of it. Now, number 4, I have ln of e to the power of x squared. So ln and e are again going to cancel out, but I want to make sure that you guys know why our answer is going to be what it is. So I'm actually going to take this and bump it out to the front and use that property. So I'm left with x squared times ln of e. And our identities that we need to know are these two right here. ln of e is always going to be equal to 1. So that's x squared times 1, which is just going to give me x squared. Okay? All right, a couple more examples. So in number 5, we have a log base 4 of 1/16. Well, I don't see much of a relationship here, but I do know that like if I square 4, I get 16. So maybe there's something here that I can do to simplify. So what I'm going to do to begin with, let's pick a different color. I'm going to make this equal to y, just like I did up in example 2, it might help you a little bit here. I'm going to do the little loop-de-loop way. So when I rewrite this, I had a log function. I'm now going to have an exponential function. 4 to the y equals 1 over 16. Okay. Well, I know that 16 is 4 squared. So 1 over 16, since it's in the denominator, is going to be 4 to the negative 2. Because it just kind of bumps it down by making it negative. So now I know that y is going to have to be equal to negative 2. Okay? Just a little way to think about this. Ooh, ln of 1 over ln of e. So I'm going to think to myself, e to what power is going to give me 1? Well, e to the 0 gives you 1. So ln of 1 is 0. E to what power is going to give me e? That's going to be e to the first. Okay. All right, moving on. Log of 1/3 equals 27. So let's set that equal to y just for the sake of explaining this. I'm going to rewrite this. From a log, it's going to become an exponential. So 1/3 to the y power has to equal 27. Well, I know that I'm dealing with a base of 3 here. So I want to think to myself, how can I rewrite 27 so that it has a base of 3? 1/3 to the y is going to be equal to 3 to the 3rd. Okay. Now, if I want to bump that down to the denominator, I can bump that 3 down and make it 1/3, but I have to now make my exponent into a negative number. Okay. So here y is going to be negative 3. Okay. Now, this last one I think is a little bit tricky. So let's take this one slow. If I were to start this the same way I started the other ones, remember, if it's natural log, it really has a base of e. If I did e to the y equals 1/4, well, e is a funky thing to work with because we don't really know the value of it. It's 2 point something is all we really know. We can get the big long decimal if we wanted to. But I can't rewrite 4 with an e in any way. So I'm going to scratch that. Oops, literally scratch it. I'm going to scratch it out. Okay, and we're going to try something else. Now, if I go up here, I have another property I think I might be able to use. I can break apart. Log of a over b has to be equal to log of a minus log of b. So let's try that. If I do natural log of 1 minus natural log of 4, well, do I know anything there? I do. I know the natural log of 1. E to what power gives me 1? E to the 0. Because remember this is e. E to what power gives you 1? It's got to be 0. Minus natural log of 4. Oops. So now I really can just kind of cancel that out. And I can just say my answer is going to be negative natural log of 4. So both of those are the same things. Now you might be saying, okay, we didn't simplify it very much. You're totally right. We didn't simplify it that much. But when it comes to calculus, they expect you to really be able to use everything that you've learned in all of your math classes leading up to now. So you never know which way an answer choice is going to be written. You might come out with this as your answer, and maybe that's the answer that's in the multiple choice parts. You have to be able to recognize the similarities and the differences between each form and how they relate. So there's some practice with this in the classwork. So work on that. And I know that this is one of the trickier subjects. So if you guys have any questions or you need any additional help, let me know. I'm free during the week. If you guys want to, pop in for a little Google Meet, I'm totally willing to do that, or just email me and we can kind of chat back and forth. If you guys need my Google Voice number, I'll post it on the Google Classroom page as well. So if you guys want to text, you can text as well, and I'll help you guys to make sure that you guys are prepared.